So ready to start. We can enable all three microphones. So welcome to the SQL MI demo party. You're going to see some new exciting things about MI. We have prepared a selection of demos of new things we've done. And without ado, it's going to be three of us, three presenters. So my colleague Uroš.
Hi everyone, Uroš Milanović, Product Manager, SQL Managed Instance team, platform guy from the very start of my journey in Microsoft, so happy to be here.
My name is Danny. I've been since Managed Instance team since the day one, worked on various topics from high availability, MI link, monitoring, intelligent performance. I've been around MI for a while. Thank you.
And my name is Nevena Nikolic. I'm also from SQL MI team, and I primarily work on the performance part, usually tuning, monitoring, performance. Yeah, these enhancements. We'll be talking about this today as well.
Okay, very good. Let's start. Uroš is first. Thank you.
Thank you. So just a reminder about the sessions. We are on the What's New SQL MI demo party. More sessions coming tomorrow and Saturday. Hope to see you there as well. So we have 4 demos for today. Some of them will be a bit faster. Some of them will have the regular pace, but business continuity, disaster recovery, data mobility, and next-gen general purpose that we saw a couple of hours ago, and then a bit about the cost optimization in SQL MI. So starting with BCDR, as I mentioned, since I'm in the platform, just a reminder about the disaster recovery and business continuity options that exist in SQL MI. So there is, in PaaS world, you have the automated backups where you're able to configure the redundancy for the storage used for keeping them. If you use geo-zone redundant backups or geo-redundant backup storage, you are able to perform geo-restores, which can be like the entry level of having the disaster recovery in SQL MI. Then since recently, not so recently in Azure, but recently in SQL MI, there is a zone redundancy option available for both business critical and general purpose service tier, which spreads the MI across multiple availability zones within one data center. And then finally the failover groups, so configuring totally separate managed instance in another region and establishing the failover group between them so that the whole region, all zones go down, you can easily fail over to another region. Besides the disaster recovery option, this also is a regulatory and requirement in some industries. So we see different drivers for adopting this capability. As we mentioned, the zone redundancy becomes the new standard, so it becomes the recommended way for running your both applicational and database layer. I think that we also saw yesterday, so when you're on a platform as a service, your service is responsible for executing deployments on multiple layers. There are available options today, the maintenance windows. They're not so flexible, I would say. They are maybe a bit robust, but still give you a predictability and ability to control when these deployments are executing. They are not constant, but they happen. Thanks to Service Fabric, which is the orchestration layer for providing high availability of the service, these deployments are going in an online way with the failovers when we need to switch to another VM in order to maintain the one containing the primary. Now, what we'll see now is that failover groups can help in being more in a control about the failover moment that can come as a result of the maintenance capabilities. So what we are going to do, we are going to create 2 different managed instances with different maintenance windows. Our primary will have the weekend one, our secondary will have the weekdays one. So they will never have the maintenance at the same time, and you can use failover to switch between them to avoid these interruptions and be in a control over the failover moment. So as a step 1, we are creating a primary managed instance. So as step 1, we are creating the subnet. So MI runs in an isolated environment in a customer VNet and subnet, and we need to create different subnets in different regions for them. And they need to have different IP addresses. So in order to establish connection between those VNets, you cannot have overlap in IP address space because the VNet peering will not work. So what you have to do is create subnet in primary region with one subnet range and totally different range in another region. After creating the VNet in subnet, you will be able to deploy SQL MI. But before creating SQL MI, you can establish the peering, which is actually like expanding your virtual network. Yeah, you're saying like, hey, these two virtual networks are now the like one, and in order for traffic to flow between them in failover group setup, you need to establish the peering in bidirectional way, which means you say, hey, my primary network can send and receive traffic from secondary, and I confirm that it also can happen from secondary to primary. And when you use Azure Portal, this template helps you to have this in from a single with a single action. So what this actually will do, create two peerings from primary to secondary and secondary to primary. And we initiate create, we can see that actually two options are initiated in the background. So what we have achieved now, we have two VNets, two subnets inside them, and they're peered between. Cool. So step one completed. In a step two, we are configuring a primary instance. We will use the East Asia region, give it some name, so indicate it is our primary, and we are going to select the pre-created subnet. Why we are not using the new the option for creating new VNet and subnet from this create screen, but using the pre-created one, is because the new VNet from this option will give us the default IP address, and it will do the same for our second instance, which will create the overlap. So we need to pre-create with certain IP address range, but we do not need to do anything else, because when use Azure Portal for creating instance, the deployment will do all requires stuff for creating a network security group, route table, and populating the values inside it. Then we need to select the desired maintenance window. We said that for primary we are going to use the weekend window that spans from Friday to Sunday, and we will keep the option for failover secondary to no. We will leave that for our second instance. What is also important is that configuration that we used for our primary instance in the terms of service tier, hardware generation, vCores, is recommended to be used on the secondary as well. So they perform in the same way. So we created our primary SQL MI, and now we need to create secondary. For secondary MI, we are going to use the same options but different region. We are going to Southeast Asia, which is the paired region for East Asia. And we are going to select different VNet and different subnet that we created in this region. And the deployment process will do the same, prepare it. Now, we need to configure two options differently. We need to select the weekdays maintenance window, so Monday to Thursday. Our primary is Friday to Sunday. And we must mark that we want to use this instance to be the secondary instance. And not only that, we need to select the specific primary that we want this secondary to connect to. What will actually do this in the background, it will put the primary and secondary within the same DNS zone. So additional layer that protects your managed instances, so there is no inflow of some other traffic. After completing this, we can create our secondary instance. Another reason why we used the paired regions, so East Asia and Southeast Asia, is because the regional pairs that are documented publicly have direct connectivity. So with this and VNet peering, you had the maximum possible performance because besides the hardware configurations of the instances, the VNet configurations also impacts the performance of the failover groups. Okay, so we have VNet subnets, we have instances inside it. For configuring failover group, we have one additional step. And that is, as you mentioned, VNet and subnet are dedicated to SQL MI. They have some basic rules that get deployed during instance creation, but by default, they do not allow actually the traffic to flow between those, within the failover group. So we need to add additional rules into our network security group. Those are ports 5022 and 1000 to 1099. And we need to add those rules for both inbound and outbound traffic on both subnets, primary and secondary. So 2 rules, inbound and outbound, and 2 rules, inbound and outbound on primary and secondary subnets. In this scenario, we are configuring that on these rules can only serve the traffic between virtual networks. And that is, I would say, some medium level of security. You can further tune it down to specific IP address range, to specific subnets that you used for your primary and secondary subnet. Okay, we adjusted the network security groups. They now allow traffic to flow between those subnets. Now we are going to configure failover group. If we don't have these rules previously added, the creation of failover group would fail. It would try to push the initial traffic between, and it will say, okay, I cannot push it. Please go adjust your rules. But since we did it, we can create our failover group. We are giving it the name. The name is important because we will using it for connecting now to our SQL MI. And the failover policy will be put to manual. What this means actually is that we will define if there is a downtime in our primary region. And we also want to include the failover rights, which means that we are claiming that we are not going to use our geo-replicated instance for read-only purposes, which is allowed option. And if we don't use it for read-only purposes, we can save on cost because license is not charged. Once the failover group is established, it will get the read-write listener endpoint that we will now use to connect to our managed instance. We will not anymore use the endpoint that is directly on primary or secondary instance. And the system will know, depending on which instance is primary or secondary, to route the traffic automatically. So you don't need, after the failover, you don't need to change the connection strings. You simply connect to the listener. Okay, so we now have the failover group setup. We can fail over between primary and secondary, but how to know when to fail over? Azure Monitor is the service that has a sub-service called planned maintenance that has a role of announcing the maintenance events of the services. In this case, we are interested in maintenance events of SQL Managed Instance. So we have a list of all maintenance events that you can filter per subscription, region, service. And when you enter one maintenance event, you can see is it the maintenance or something else, to which region it is scoped, to which services it is scoped, and you can also check the list of impacted resources, which is very important because you might have multiple resources in that region. Only one of them is your production that you have failover group set up on, so you need to react only when there is maintenance for that resource. Then you can create alert rule for these events. So for desired subscription, region, and service, you create alert rule that reacts on it. Unfortunately, you cannot create it per resource individually, so you cannot create it per specific instance. It has a limitation that it can only be scoped to the service, region, and event type. In our case, planned maintenance event in East Asia, where our primary is, and SQL Managed Instance. And then we define the action. In this demo, we will use the email, so we will receive the email around this event, but it can be anything. It can be triggering the automation runbook, Azure functions, so you can automate the stuff through some PowerShell scripts or some other way. So we're giving some friendly names so we can distinct if we have multiple alerts to distinct that this is the one that we should react on with a failover. And we will create this alert. Now we can expect the emails anytime when there is a maintenance event for our instance. This is the example of the notification. You get tracking ID that you can correlate later if you go to service health or you're creating automations. There is the status of it, the type, when it is happening, and there is a link to check the impacted resources, or you can go directly to Azure Service Monitor. Finally, when we have alert, we are able to execute the failover. So we are going back to SQL Managed Instance to failover group setup. There is a button for failover. It is important not to use the forced failover. So we are using the failover that will actually failover gracefully. So we will wait everything to complete on primary, do the failover, and then repoint to the secondary. So let's imagine that it is Thursday. We got notification that there is a maintenance coming on Friday. At that time span, the advanced maintenance notification is sent 24 hours in advance. We have time to react and through some quiet hour period to go to fail over to secondary. Once the maintenance is completed or the weekend is completed, we can go back. So with this, we finish the last step. So it is important to mention that this is not like the mandatory option. This is a thing that can be helpful in case that you have failover group setup, or you have a strict need for being able to control the failover moments because system is, for example, not sufficiently resilient to this. Retry logics can help in overcoming the failovers. By default, the upgrades are online operations, and if you rely only on high availability setup, the service tier, you will have failovers during the maintenance window, while in planned failover concept with geo setup, you actually execute the failover before the maintenance window. In both cases, there is no data lost. Number of failovers different. For when you rely on maintenance on high availability, it can be a couple of them, depending on the layout of the machines in the background. While with planned failover, you go to secondary region and you go back, and you are in control when it happens. For maintenance windows, failovers can happen anytime during the window, but they are shorter. There is no increase in latency. There is a replication of system databases, and there is no extra charge. While in case of geosecondary replica, you're actually spinning the totally another resource in another region, which increases the costs. So failover groups are the concept for replicated data between different Azure regions. And now my colleague Dani will show a bit of replication.
Thanks. Appreciate it. So the topic that I'm going to cover is about data mobility. And imagine that you're running the service on managed instance and that you need to move your databases around, or maybe you have a SQL Server, and with the SQL Server, you also want to move your databases to manage instance. So I'll cover both scenarios. So maybe you're familiar with the feature that we have that's called MI Link, which was already released for some time. And this is just a recap. It allows you to create a near real-time replication from SQL Server to managed instance. It uses always-on technology, so it's instantaneous. So you can essentially connect to managed instance without migrating, without moving to it. So let's say you're on-premises SQL Server, you want to evaluate, you set up this link, you replicate your data to MI becomes secondary, and then you can use Azure. So that's one scenario of it. Now, with SQL Server 2022, because managed instance is SQL Server 2022 compatible, it is possible to do a disaster recovery. So it is possible to have MI as a primary as well as the secondary. That is not possible with the earlier SQL Server versions because of the compatibility. But using the SQL Server 2022 and MI Link enables you then bidirectional failover in two ways. Now, a new thing that we have just added, and it's available in the latest release of SSMS, and of course it's all documented on Azure Docs, is the ability to create the link starting from managed instance to SQL Server. So let's say that you have already migrated to the cloud, you have a production database on managed instance, you want to sync your data back to SQL Server 22. By the way, it's only SQL Server 2022 compatible. That's how you can get your data back on SQL Server 2022 with the real-time replication. And then you can control, if you want to have a failover, you can control that failover. And that is also a way for compliance. Let's say some companies, so either for exit strategy from cloud or for compliance purposes. Sometimes in a highly regulated industries, you need to show that you can actually export the data back. There's another way, of course, there's doing the backup and restore. You can make a backup on managed instance and restore it to SQL Server 2022. But this is near real-time replication where you actually need that flow of data. So in this case, MI is primary and managed instance secondary. And this is the third part because we've already in the previous years have seen demos on the first two parts. I'm going to demo the third part now, which we're revealing in public. One note, because demo is a bit quite quick-paced. Managed instance has the data encrypted, or the databases of managed instances are encrypted with a TDE encryptor. So it's either Microsoft managed or customer managed. If it's customer managed, you need to replicate both keys, your encryption keys, on managed instance and on the SQL Server. However, if it's a Microsoft managed key, you either have to decrypt your database or you would need to set up your own key because when database is Microsoft managed, Microsoft encrypted, it is not possible to get that key. So that's a note. Without further ado, to the demo, here is my SSMS setup. Here is where I have a managed instance. And then up there, I have SQL Server 22. So that this is the setup that I'm using. And in here, I'm going to turn off the TDE encryption on managed instance because I had Microsoft manage encryption. There are 2 entry points. One, you can click on a database and create the link, or there's a new option that is now shown, which was not available before. Always on availability group menu is enabled on the MI side, which was not visible before. And that's another entry point where you can set up the link from MI to SQL Server. This is our standard prompt. You would create the link name. You would choose a database or databases if you have multiple to replicate from MI back to SQL Server. You would click on next. You would check if there are any rules needed. Then in this case, you would add the secondary. So my managed instance is automatically primary here. And then I need to add secondary, which is my SQL Server. So I need to provide the connectivity and credentials. Now I'm logged into SQL Server as well. Here are some pre-checks to create the link. If everything is fine, everything is green. We will do some certificates exchange, security exchange. Here's the final list before creating the link, and then the link will be established. By the way, you can use the scripting to create a script if you want to see all the commands and execute everything manually. But of course, all of that is automated in SMS. So what we've seen here after creating the link, that the link has been established. Now MI is a primary and SQL Server is a secondary. We see on the SQL Server in the always on high availability section that there has been link created, DAG MI link test DB. And similarly, then on the managed instance, we see that the link, which uses distributed availability groups, has been created. And let's just zoom in once again. See that, so they're all match, showing that MI is primary, SQL Server is secondary. So let's see if querying works. So here is a insert on managed instance, and then we see that the data has automatically appeared on the SQL Server. So all the data that we now put in near real time on managed instance is going to be automatically transported back to SQL Server 22. And it's going to keep going on forever until, and there is another command, until you do a failover. So either you can do a migration to a SQL Server, or you can do in reverse the failover to switch the roles where a SQL Server becomes primary and MI secondary. So that's an update that we have for MI link feature. Another thing for which we heard customers asking us about was the need for listener endpoint. So when you do the failovers between SQL Server and managed instance, before you had to manually repoint your application to the primary and secondary. So follow the article, the link that we have provided at the bottom. We have actually now built a solution which is based on DNS alias, which enables you to have a single connection string, and then if there is a failover, it's going to automatically follow the primary. There are some limitations, however, at this point in time, that the host name of the SQL Server must match managed instance, and all the details are available. But we're moving towards making this experience better and more seamless. Next, I want to talk about is about data mobility between, or online data mobility between different managed instances. So let's say you are running in a managed instance in the cloud and you have your production on managed instance, and for whatever reasons you want to move your production database or copy to another managed instance. But of course, you can't afford any downtime. Backup and restore may be not an option for you because that takes time and involves downtime. So we have implemented similarly an always-on replication technology between managed instances, where it is now possible to, in an online manner, copy or move your database from one instance to the other. Now, I will show you a couple of demos, but I also note that when we start the copy, it's continuous until we actually cut it over, and also for the move. So it keeps copying until we actually determine the cutoff point. So the customer controls the cutoff point in time of the snapshot data they'd like. Without having ado, so here we have two tabs. I have two managed instances, MI1 and MI2, and I have a couple of databases in there. And I'm going to first do copy. I just click on the copy option. It's a simple to use user interface. I choose my secondary MI, and I go start, and then replication start. So now database is being copied from MI1 to MI2, and it says copy in progress. So that's the initial seeding of the entire database from one managed instance to another. On the refresh, when the seeding is completed, when the database is in catch-up mode, it's ready to be cut over. So I can do complete, which essentially is point in time where this database is going to be cut over. After completing that, the copy has been completed, and at that time when I clicked, the snapshot of data has ended, and that exact copy at that point in time of the entire database is available on the other managed instance online. And that's really a way, without any downtime, to copy database from one MI to the other. Similarly, I would like to show a move version of it, which is very similar. I would go also to my MI1. I would choose a database to move. Instead, I would just choose the option to move. I would have a very similar user interface where I need to choose my secondary MI to which I need to move the database to. I start first the replication, so it's the same process. And the status of it is that the move has started, so the database is getting seeded. When it's ready, then the database is in catch-up mode. Any new commits are transferred, and then customer has a control of the cutoff, which is the complete button. And at that point in time, when you have clicked, then that's the point in time where you have actually moved the data from one managed instance to another. If we go to our second managed instance, we see that the move database has appeared. It's on there. However, it's also interesting to note that on the first MI, the previous database that was moved is now shown as gray, such that it has an indication that it has moved. So this is really a great way to move your databases and copy them online from MI to MI. So that would be all that I had. Thank you.
Thank you, Danny. Next one. Do I work? Okay, perfect. Yeah, next-gen general purpose. I'm not going to do any intro slides because this really doesn't need an introduction. It's going to talk about it itself. So this is a Azure portal, and I have my SQL Managed Instance, general purpose. And as you can see, it has 16 vCores and 2 terabytes. It can go all the way up to 64 vCores and all the way up to 16 terabytes. These are current limitations for premium series memory optimized. And we now see this next-gen GP, which is in preview since today. So enabling it, we see something changes. Now we have many choices of vCore, and once we reach 32 vCores, we can also go all the way up to 32 terabytes of storage. So, it's doubled than it used to be. Remember, it was 16, now it's 32. And you see another slider, which is complete game changer. It's new in industry. So this is the IOPS slider. So you see, you have some default IOPS given to you, but you can increase the IOPS. You can be, I want more. So if it's not enough for you, just increase your storage and you get even more IOPS to provision. So, that would be Azure portal. But now let's do some performance tests and the performance comparisons. On my left-hand side, I have general purpose, kind of general purpose, and on my right-hand side, it's actually the opposite for you. I have next-gen general purpose. Okay, I made sure these are both equal configuration. So equal number of vCores. I chose 8 because it's the most frequent one for the customers, and I chose the same hardware generation beneath. So yeah, these are the same configurations, just this is general purpose, this is next general purpose on the right hand side. And let's start this. This is TPCH 10. Why 10? Well, just for the purpose of this presentation, so that it can finish when we finish the presentation as well. So let's keep this running in the background while we start another comparison. Once again, left-hand side GP, right-hand side next-gen GP. It's called Hermes over there. Hermes is, yeah, because it's of a God speed. Hermes was our code name at the time. Okay, so we kick off the actual workload, and we can see straight away that next-gen is has more transactions per second. It's an order of magnitude even. So, okay, 45, 44K, 47K, and here we had max 7K. Okay, we'll also keep this running in the background while I show you another thing that NextGen brought. And that might blow your mind because it was one of the most wanted features for years now. So maybe, I'm not sure if you see this message, this 41912, it's a message that you actually reach the maximum number of databases. And I suppose you hate it as much as I do, and I did, let's put it that way, because the maximum number of databases on GP used to be 100. And now we basically increased it not twice, not 3 times, but 5 times. So now you can consolidate even 5 of your earlier MIs to one MI now. So combining this with what I showed you, like 32 terabytes and some more storage, more vCores. Now we have up to 128 instead of 64 or 80. So combining this all together, you can basically consolidate many of your workloads into one MI. And this is like a huge cost saving. And okay, let's go back to this workloads. So let's just see what's going on here. Look at the peaks. It's 250K and GP only 7K. It's incomparable. So basically what we did here, we put this IOP slider to the maximum. We wanted to show you basically what maximum gives you. And while on the other hand, for this TPCH that's still running for the GP, okay, we're gonna let it finish. And in the meantime, we're gonna look closer to the next-gen GP results. It completed the query set in 112 seconds. 112 seconds for the query set for TPCH 10. And what happened to the GP? Okay, it finished in the meantime. Let's look at the numbers. 313, so 3 times more. It really needed 3 times. And remember, the same configuration, same number of vCores, same underneath hardware. Okay, so this is what we're promising to you. 3 to 5 times better performance for the next-gen GP. Thank you very much. Cost optimization. I'm calling my colleague to join me here.
Thanks, Nevena. So we saw a bunch of capabilities that you would like to try out. And we will now go into the cost optimization area and how to do this for like the smallest possible price. like some typical environment build flow that we are seeing is that like you're starting with proof of concept and validation, like observing is this services or any services is right for your project. Then it goes into development and testing phase, and then it starts with like one production environment, and if like the business scales or it has a solid number of customers, it can go into the expansion phase where you're running the fleets of resources. So for proof of concept purposes, since recently there is available free SQL Managed Instance where you get at your disposal 750 vCore hours of compute and 64 gigabytes of storage. With next-gen GP that Nevena mentioned, you also get 300 IOPS included. So both current and new general purpose tiers can be tried with this capability. You get it in your hands for 12 months, so it renews every month for the 12 months, and we will see like a short demo how you can use it. So by going to portal, there is a new informational box that you can apply this free trial, and when you apply, your cost per vCore and storage and IOPS is set to 0. All you have to do is select your demo, your resource group, name your, give your SQL Managed Instance the name, or keep the default one. There is no much need of configuration because you can only scale between 4 and 8 vCores and go between 32 and 64 gigabytes of storage. The IOPS is fixed at 300. This is the minimum that one instance cannot go below. And since the available storage is 32 and 64, this is about the ratio of 3 IOPS per gigabyte that is being given on some bigger storage configurations. Once you click create, in approximately 20 to 30 minutes, your instance will be created. Ignore the message on the top is there because not all cases still support these shorter provisioning times. So again, when you create this SQL Managed Instance, your vCore hours start running. If you run out of them, the next month they will be renewed. The free SQL Managed Instance leverages the benefit of start-stop, which is another tool that can help in cost optimization. When you create free SQL MI, it immediately gives you the start-stop schedule that we will see later. But this benefit can also help you with regular instances. So you don't want to or cannot use free SQL MI, or the trial period has expired. Now you're entering the development phase. You need some extensive development, more resources maybe. The start-stop is the tool that can help. On one example of 4 vCore GP instance that is active only from 8 a.m. until 6 p.m., so some, let's say, work hours during work days, you deploy that resource on dev test sub and your license costs are not applied. So you pay only for the compute. Then you turn on the start-stop, or you actually start using the start-stop feature. Start your instance at 8 a.m., stop it at 6 p.m., and your costs are much more cut. If you are aware that like your development project will take some time, or you have multiple resources that you need for developing during that period, and that have different working hours, for example, dev team in on one part of the world, another team in another part of the world, you can apply the RI benefit and pay upfront for the compute that will be used. And this benefit can also be combined with other, like use it for dev test sub. Reserved instance pricing works on dev test subs as well, and you can use start stop to further optimize the cost. Now, when using start stop capability, there are 2 ways to start and stop your instance. If you don't have predictable working hours, you can use the manual way. So you have start button and stop button. You trigger it, wait for operation. Don't have to wait for operation to complete, and you are like in manual control when these events will happen. But in case that you have predictable working hours, like we saw from 8 a.m. until 6 p.m., you can configure a predefined schedule. So you define on Monday, I want my instance to be online from that point in time to that point in time. You can have multiple stops during one day. So Monday can have 2 or 3 start-stop pair items. And on the very bottom, you have a line that shows what % of the time your instance will be will be stopped, which directly translates into the cost saving of running one resource. Now you completed your dev test, you're going into the production. Production is running 24/7. There are other benefits that also help with your productions, including Azure Hybrid Benefit for bringing your on-prem licenses and saving on licensing costs, and the reserved instance capacity that we mentioned. In case that you are running a failover group setup that we saw in first demo, and your failover replica is only for disaster recovery purposes, so not used for read-only workloads, that license can also be excluded from the cost, so you pay only for the compute and storage of that resource. To calculate how much your production environment can cost you, you can leverage the Azure pricing calculator where all these options are available. So you select the configuration for your instance from the perspective of region, the service tier that you will use, the type of the instance, single or pooled, hardware type, vCourse, disaster recovery, is it primary or secondary instance, and then you can start applying the cost-saving options. You're starting with pay-as-you-go, but then you can further and you get the price for it, and then you can further turn on like the dev test pricing if you want to calculate how much your dev test environment will cost you. There is a button at the bottom of it, and it will apply to all resources that you add here. As we can see, the license costs are cut. The same value would be achieved if you activate the Azure Hybrid benefit. So this is also the way when capability of bringing your license that you already have, and on SQL Managed Instance you pay only for the compute and storage, and of course backup storage. If you commit, so long-term commitment, 1 year or 3 year period, then you get additional discount price, and we can see, for example, how many you would pay for one SQL Managed Instance for which you have license and it is configured as the primary. If you're selecting geosecondary, the price would be the same. But what if you have a lot of instances? Like either you're like ISV, you have instance per customer, or you have a lot of tier 2, tier 3 applications that are not so demanding, and you need 4-week core options is too much for you. Like I think from a month ago, the public preview has been refreshed for instance pools, so we are continuing investment into this deployment model. And instance pools are the deployment option where you pre-provision certain compute where you can spin up multiple instances inside. So you get the certain amount of compute, and multiple SQL instances get created inside. The benefit of the instance pools is that you can go to vCore, which is not to 2 vCore option, which is not possible for standalone instances. The lowest possible option is 4. And you can another thing is that since compute is provisioned, creating the instance inside the pool is fast operation. So it's simply spinning up the new SQL process and assigning some already provisioned compute to it. During refresh, the reserved instance benefit has been also included for instance pools. Pools can now be scaled. You can move instances in and out. This is also the online operation, and you can use premium hardware besides the standard one for creating one pool. So how it looks like, similar to some options that are previously were on the instance level are now on the pool level, including with main capabilities being the hardware that you're going to use. You select some region, standard stuff, and then you cannot select the tier because pools are supported only for general purpose. You can choose the hardware generation. At this demo, this cannot be seen, but it is available to choose premium series. And you can also apply Azure Hybrid Benefit, so bring your own licenses. When you go to the standalone instance, you need to select that it belongs to some instance pool, so that you don't want to standalone instance, you want the pool instance. By toggling this option to yes, you will get the drop-down selector for selecting some instance pool to put this instance in. we will see that there is a pool that we previously created. You select it, you create auth method for it, and then you go to additional configurations. And you can see that you cannot now control the service tier and compute hardware because it is inherited from the instance pool. And the vCore and storage can be scaled up to the limit or pool if it is first instance, or up to the available space in the pool. If there are other instances, if there is no space, you will get a warning message that you cannot put this instance inside this pool. Again, networking cannot be changed because the pool is already provisioned inside some subnet, and these are all the rest are standard options that are actually options on the instance level, except the maintenance window that are again something that is compute specific and assigned at the pool level. And in a couple of minutes, your instance will be created because there is already a compute. You're just spinning up a SQL Server on that compute. And this is last demo for today. Thank you very much. I think we have 1 more minute for some questions. Yeah. Do we have a mic for the question? Here is another one coming.
This one is off.
Just a second.
Just a second.
Testing. Okay, it works. Okay, we
question
have
for the instance pool.
4 minutes.
So you allocate, does it work like similar to Azure SQL DB? Because let's say you have a pool of 16 cores. You allocate it to four instances, 4 cores each. Can you stop each instance and pre-allocate the resources to one to kind of power it up?
No, it is not available. Currently, it works only in a provision mode, so you cannot over-provision pool in that way. But this is a good feedback that we hear that we plan to work on, so we can talk later to see about the scenario. But I understand the question. It's not like in Elastic Pools where they spike.
Yeah, because you have the option to stop an instance and kind of limit overfeeding the pool because you're taking too much cores for which you provision the pool. But thank you.
It's like this is first iteration of public preview patch. There will be more, and let's talk about the scenario definitely.
In front.
Thanks. Looking at the new copy and move feature in SQL MI, looking great. I'm wondering, is there any good, and I mean good way to move a database from Azure SQL database to managed instance? Because I know there are ways, and they might be feasible for smaller databases, but for big ones, it's really kind of a problem for me.
Unfortunately, not at this time. What you can have, if you have a large number of databases that you want to move, you can reach out to our support, and there are ways where support can migrate that for you as like a one-time service. But in terms of actually automating, having that click, we don't have that yet. We hear about those asks, but it's not yet productized. Oh, Nico wants to add something.
There is a solution by David Maury, Smart Copy. Smart bulk copy. It's on the GitHub. I'm happy to give you later a link for quite some time. So it's one of the best ways of copying the database between different environments like DB and MI. And you can use also ADF to replicate it. But that's the best what we have now. Also, do not forget that there is one little issue. That we have a product that runs the full compatibility with SQL Server 2022, right? And the SQL DB does not have the compatibility. And some of their features, as of today, I need to be specific on that, they're already requiring the storage engine support. For example, all the, the JSON enhancements, which are already been made public, there is no equivalent in SQL Server 2022. So any attempt to copy those would fail. And as you know, that restoring from a future version to a backward version cannot be automated. So that's kind of like the problem space.
Thank you. So third-party tools. Thank you.
Question
We have,
back,
we're at time. Was there
one
another
more question?
question?
Please.
One more, and then we're done.
It's short.
Yes.
Does the next gen have any dependencies on the November 2022 wave?
Yes,
question.
yes. Only instances with November 22 feature wave can turn on the next gen GP. If you have the existing instance and it is running with feature wave capabilities, you can turn on. If not, you would have to create a new VNet empty. As instance created inside the empty, new VNet will by default have the feature wave and be able to immediately turn on the next gen GP.
Yeah, every new VNet
Yep, yep.
will have.
So we're at time. Thank you so much, folks. We'll be available to take questions offline and also at the Microsoft booth. Thank you.
Thank you.